Did you know that the longest underwater tunnel in the world, the Seikon Tunnel in Japan, is 53.85 kilometers long? Quite a feat, isn't it? Well, welcome to the intriguing world of underwater construction, a realm where engineering meets the depths of the sea, and human ingenuity dives deep beneath the waves to create marvels that defy our imagination. You see, underwater construction isn't just about tunnels. It's about the Channel Tunnel between England and France. It's about the awe-inspiring underwater hotels like the Conrad Maldives, where you can literally sleep with the fishes in the most luxurious way possible. It's about visions turned into reality, about pushing boundaries and defying what we once thought was impossible. These structures bear testament to our relentless pursuit of innovation. Our quest to master not just the land we walk upon, but also the waters that cover the majority of our planet. It's about the audacity of the human spirit that looks at a body of water and thinks, yes, we can build there. Underwater construction brings together a multitude of disciplines: civil engineering, marine biology, architecture, and many more. It's a symphony of knowledge, teamwork, and technology that results in structures that are as functional as they are fascinating. Each of these underwater marvels has its own story, its own set of challenges that had to be overcome. Every tunnel, every hotel, every underwater structure is a testament to human grit and the power of innovation. They stand, or rather, lie beneath the surface, as symbols of what we can achieve when we refuse to be limited by our environment. And while they may be out of sight for most of us, these underwater structures play a vital role in our everyday lives. They facilitate transportation, they boost tourism, they push the boundaries of luxury, and they even contribute to scientific research. Now, you might be wondering, how are such structures built underwater? The process of building underwater is complex and poses unique challenges. It's a fascinating world beneath the waves, but it's not without its hurdles. Think about it for a moment. The immense pressure of the water, the unpredictable weather conditions, and the limited visibility. All these make underwater construction a feat of engineering wizardry. Let's start with the pressure. As we dive deeper into the ocean, the water pressure increases. This rise in pressure can affect the materials we use and the workers who brave the depths. This is why special equipment and materials designed to withstand these pressures are used. Then, there's the weather. On land, we have to worry about rain, snow, and wind. Underwater, there's the added complexity of tides and currents. These can cause delays and even pose safety risks. Hence, careful planning and scheduling are crucial to ensure work is done during the most favorable conditions. And let's not forget about visibility. Underwater, we don't have the luxury of clear, bright sunlight. Instead, we deal with murky waters and the gloom of the deep sea. This makes tasks like inspection, installation, and repairs a bit more challenging. To overcome this, we use advanced lighting and imaging technologies to illuminate our workspace and capture clear images. So how do we go about building underwater? It's a four-step process: site investigation, design, construction, and maintenance. In site investigation, we examine the seabed and the surrounding environment. We look at factors like soil type, water depth, and marine life. Design involves creating a plan that considers the unique challenges of underwater construction. It's here that we decide on the materials, equipment, and construction techniques to use. The construction phase is where the action happens. This is when our plans come to life, with structures being built and installed. And finally, maintenance. Regular checks and repairs ensure the longevity of our underwater structures. Let's delve deeper into these steps. The world of underwater construction is an intriguing one, filled with complexities and challenges. But with the right knowledge and tools, we can create marvels beneath the waves. But before construction can begin, the site must be thoroughly investigated. This is an essential step in the process of underwater construction. Picture a team of experts, armed with state-of-the-art technology, venturing into the depths of the ocean. They're not there to admire the marine life, but to conduct a meticulous examination of the seabed. This phase of the process, known as site investigation, involves geological and geotechnical surveys. The geological survey provides a detailed understanding of the seabed conditions. It reveals the type of soil, its composition, and other crucial information. On the other hand, The geotechnical survey assesses the mechanical and physical properties of the seabed soil. This information is vital for the engineers to determine the feasibility of the construction. These surveys are a blend of science and engineering, ensuring that the site is safe for construction and will be able to support the proposed structure. Once the site is deemed suitable, the design phase begins. Designing an underwater structure is a careful balancing act. It's a high-stakes chess game where engineers need to consider an array of factors that can affect the integrity and functionality of the structure. First, water pressure is a significant component. It's like a constant invisible force that pushes against every inch of the structure. As you go deeper into the water, the pressure increases, becoming a formidable challenge that engineers must address in their designs. Then there are the currents, the silent and powerful rivers within the ocean. They can be unpredictable, changing with the seasons or even daily. Currents can impact the stability of the structure and can also affect the processes during the construction phase. Engineers must also consider potential seismic activity. Underwater structures, like their land-based counterparts, need to be designed to withstand earthquakes. The challenge is even greater underwater, where seismic waves can cause water to move in powerful surges, putting additional strain on the structure. Once the design phase is complete, the construction phase begins, and it's no less complex. Specialized equipment and techniques are used to build these submerged marvels. Caissons, for instance, are watertight structures used for construction work underwater. They are essentially mobile, dry dock areas that allow workers to construct in a dry environment, even at the bottom of the ocean. Cofferdams are temporary enclosures built within or across bodies of water to allow the enclosed area to be pumped out. This creates a dry work environment for the major part of the construction. Divers, or remotely operated vehicles, also known as ROVs, play a crucial role in underwater construction. They perform tasks ranging from site inspection to the actual construction and installation of structures. But even with all these specialized techniques and equipment, constructing underwater is a colossal task that requires precision, expertise, and a lot of patience. After construction is complete, the work isn't over yet. The structure will require regular maintenance and inspection to ensure its longevity and safety. But that's a story for another scene. Until then, marvel at the intricacies of designing and constructing in the deep blue sea. Maintaining an underwater structure is just as important as building it. This is our mantra when it comes to underwater construction. The longevity and safety of these structures greatly depend on regular inspections and maintenance. While these structures are built to withstand the harsh marine environment, they are not immune to the forces of nature. The sea is a powerful force that can cause significant wear and tear over time. That's why it's crucial to regularly inspect these structures to identify any potential issues before they become major problems. Now, how do we conduct these inspections? Well, we use either divers or remotely operated vehicles. Divers are skilled professionals who can physically assess the structure, while remotely operated vehicles allow us to examine the structure without putting human lives at risk. Both methods provide valuable insights that help us ensure the structure remains safe and functional for its intended purpose. So, as you can see, underwater construction is a fascinating process that combines engineering, technology, and a bit of bravery. While underwater construction is a testament to human ingenuity and the limitless possibilities of engineering. We've dived into the marvels of this unique field, exploring how structures are built beneath the water's surface. From the basics of underwater construction, we journeyed through the rigorous process of site investigation, where teams meticulously assess the seabed and surrounding conditions. We then dove into the heart of the matter with design and construction phases, where engineers draft blueprints and workers bring them to life in the depths of our oceans, lakes, and rivers. Lastly, we surfaced to the vital role of maintenance in ensuring these structures stand the test of time and the relentless forces of nature. This incredible world of underwater construction is a testament to our ability to push boundaries and create marvels under the most challenging conditions. If you enjoyed this video and want to learn more about such intriguing topics, don't forget to subscribe to our channel.